Okay, this is a quick video to teach you about some calculations involving wavelength and frequency. Before we start doing those calculations, there are a couple of conversion factors that you need to know. Wavelengths of different types of electromagnetic radiation can be pretty small. So sometimes we're going to be measuring the wavelength in nanometers. So you need to know that in 1 meter, there are 1 times 10 to the 9th, or 1 billion, nanometers. And then with frequency, we use hertz, and sometimes hertz is too small. We need a bigger unit. So we use a unit called megahertz, which you might recognize the prefix mega from like megabytes with computer storage. So there are 1 times 10 to the 6th, or a million, hertz in 1 megahertz. All right, I just want to do a couple of practices converting between those units so you're comfortable with that. So we'll just do an example converting from nanometers to meters. So if I want to convert 350 nanometers to meters, I would start by putting the number that they gave me, the nanometers, in the top left of my conversion factor grid. And then I know that there are 1 times 10 to the 9th nanometers in 1 meter, and nanometers needs to cross out. So I'm going to put 1 times 10 to the 9th nanometers down here, and 1 meter up here. Nanometers will cross out. I multiply across the top, so I get 350 meters over 1 times 10 to the 9th. And then I just need to divide that. So on your calculator, if you remember, you would just type 350 divided by, and then to do scientific notation, I recommend that you type 1, and then hit the second button, the number above 7, which will give you an E. That E means times 10 to the, and then 9. Okay, and then if you want to turn your answer into scientific notation, if you hit the second button and then the degree button, you can change your answer to scientific notation, which is kind of convenient. So that's 3.5 times 10 to the negative 7th meters. Okay. So I wanted to also show you an example of converting from megahertz to hertz. So let's say we're trying to convert 103.5 megahertz. Radio stations are actually measured in megahertz. So all of the different radio stations that you see that you can tune between, those are all in megahertz. So like the radio station 103.5, that's megahertz. Anyway, so if we want to convert that to hertz, we put our 103.5 megahertz on the top left. And then we know that in 1 megahertz, there are 1 times 10 to the 6th hertz. Megahertz will cross out. And then I'm not going to multiply this in my calculator because I think you guys can do that. You end up with 1.035 times 10 to the 8th hertz. Okay, so that's how we're going to be doing some conversions. Now, there's one equation that we're going to kind of move around a little bit that relates wavelength and frequency. We talked about how all electromagnetic radiation travels at the speed of light, and this equation involves the speed of light, which we said is represented often by the letter C. So we know there's an equation that tells us that the speed that radiation travels, which in this case is the speed of light, is equal to the wavelength of that radiation. So we use this Greek letter lambda to symbolize wavelength. So C is equal to lambda times frequency. And this V is actually a Greek letter nu. It symbolizes frequency. You can just think of it as a V if you want. That's okay. So we know the speed of light. That is a constant. So we know that the speed of light, we're going to simplify it and just say it's about 3.0 times 10 to the 8th meters per second. It's the speed of light. And then, just to make it clear what these different variables represent, the lambda is our wavelength. And in this equation, since your speed of light is in meters per second, your wavelength must be in meters. Like, it can't be nanometers. So that's why we learned how to convert nanometers to meters, because for this equation, we need wavelength in meters. And then our nu, or our V-looking thing, is frequency. and frequency needs to be in hertz. And hertz is the same thing as seconds to the -1. Okay, now we're never going to be solving for C because we know what C is. It's a constant. But we might be solving for our wavelength or our frequency. So we can actually rearrange this equation. If we want to solve for wavelength, wavelength is going to be equal to C divided by the frequency. Or if we're trying to solve for frequency, the frequency is going to be equal to C divided by the wavelength. Okay, now this may look a little bit intimidating or confusing. We're going to do just 2 examples, and then hopefully it will make a little more sense what we're doing here. So first example is, what is the wavelength of electromagnetic radiation that has a frequency of 2.595 times 10 to the 9th hertz? So we need to ask ourselves what the question is looking for. And the question wants us to find the wavelength. So we go up here to our equations. Which one of these would help us find the wavelength? Well, it's this one, because that one says wavelength is equal to C over frequency. So we're going to use our wavelength is equal to C over frequency. We already know C is 3.0 times 10 to the 8th meters per second. Our frequency is 2.595 times 10 to the 9th. And hertz is the same thing as seconds to the -1. So I can write that as either hertz or seconds to the -1. And then all I need to do is put those in my calculator. So I would type it like this. I would type 3e to the 8th divided by 2.595 e to the 9th. And I get, and I'm going to get out of scientific notation, I get 0.12. I'm going to round that a little bit. Meters. Okay, so that's the wavelength of this radiation. Okay, one last example. This time we want to find the frequency of radiation that has a wavelength of 895 nanometers. So since we're looking for frequency, we're going to want to use this equation that solves for frequency. So we do frequency equals speed of light over wavelength. The problem is that my wavelength is in nanometers, and I know that it has to be in meters. So before I can solve this equation, I need to convert my nanometers into meters. So I'm going to do 895 nanometers. And I know there's 1 times 10 to the 9th nanometers in 1 meter. Nanometers cross out. And I assume you guys can calculate this. You end up with 8.95 times 10 to the -7th meters. Then I can go plug that in for my wavelength. So I would do 3.0 times 10 to the 8th meters per second divided by 8.95 times 10 to the -7th meters. And if you do that, you get 3.35 times 10 to the 14th hertz, or seconds to the -1, as your frequency. All right, so that was pretty fast, but that's how you solve these problems. If you have any questions, let me know. I'm happy to answer any questions. And have a good day.